Now we're going to look at some other functions used in MDX. The first one will be cross-join. At some point you'll want to combine two or more sets that have different measures on a report with MDX. This is where cross-join comes into the MDX solution. Being able to mix measures is going to be a requirement from your end users. There are two syntaxes for cross-join. One is to wrap in the two sets, typing cross-join, then an open parentheses, and list the sets separated by comma, and then close the parentheses. The other is to use an asterisk between the two sets. Time intelligence is used in almost all cubes. With a date dimension, time functions can be applied to measure calculation. These new measures are used for trend analysis. Previous period is a function that can compare the measure from the current period to a previous period, which can then be placed on the side of that current member and then calculated to show something like percent growth calculation. This example shows a period to date function used inline on the rows with the calendar date hierarchy sliced by years and month. Here you see order date dot calendar date dot month, and since it's a hierarchy, the first reference ampersand 2011 is to the reference of the year key, then ampersand April is a reference to the month value. If you notice, you did not need to put the quarter between those two, since those levels of attributes are in the calendar date hierarchy. They can be referenced as what you see on the screen. To simplify this, you could use the YTD, QTD, and MTD to get the same results. This is also our first look at predefining a measure for use in MDX. In the example, you see the with member at the top. With member is creating a new measure called YTD Internet Sales, as, and even a new function, aggregate, which takes the aggregate of the measure that you're using, in this case Internet Sales, and uses the same aggregation on it. And in this case, that's sum. And what it's looking at is the year to date of the order date dimension of the calendar date hierarchy, and then the current member. When this is referenced in the select statement, it'll find and calculate that year-to-date Internet sales along the side of the Internet sales in this example. This is a great example of how these time intelligence can be used within MDX. Next is navigating the hierarchy. With hierarchies, you're able to navigate up and down and across through various functions. The descendants will be the members of the next level for the current member. Cousin will look at the same level or members from the ancestor's next member. This is like quarter 2 when referencing quarter 1, or February 2011 when the current member is January 2011. The ancestor can get the member directly above the current member. In the case of quarter 1 of 2011, this would be the value 2011. Some of these functions provide you the ability to specify the level as well as the distance up or down the hierarchy, so you're not just looking at the first or next member. Let's look at a demonstration of more MDX functions. We'll first open SQL Server Management Studio and connect to our Analysis Services instance. We'll go to the database, AdventureWorks DW 2014, create a new query window. Let's review again the members function. Here is where we reference the actual member at the hierarchy or the level of the hierarchy of the member. In the first case, we're going to see Internet sales on our columns and the product categories. Next, we'll see that when we reference the attribute, we would no longer receive the all member. And then using the non-empty, we can get rid of the rows that don't return a value. Now, let's go ahead and look at our cross join, which will use some of these similar ideas. I'm going to open up a previously created window and look at the cross join. So here we're going to do an example of a combination of tuples, the years 2011, 12, and 13 on our columns, and then display the actual product category attribute members along with the internet sales. So here, if you look at the example below, we have the sales for those particular years. Bikes have sales for 11, 12, and 13, but clothing and accessories only have for 12 and 13. Now, in our cube, we also have reseller amount. So here, we want to actually cross-join the categories with two different measures. And if you see the function cross-join and the open parentheses, the closed parentheses is below. Here's our second set and our first set. The first set is the members of the product category, and there's our comma to separate the two sets. When we launch this, you will see now that reseller sales becomes available in the same output. And if we wanted, we could wrap the non-empty in this cross join as well to get rid of those null values. But if you see here, we're able to look and compare the internet sales with reseller sales for the product categories bikes. Next, let's look at some time intelligent functions. Again, I'm going to open up a previously created query so we don't have to type this all in ourselves. The first one's going to be the periods to date. Here you can see that I have each month of the internet sales and how much it was cumulative to that particular month. Again, we're referencing in here the dimension order date, the hierarchy calendar date, and then we're down at the month attribute level. But in order to get that month, we at least need to reference the year along with that particular month. So here the function periods to date is going to go to the April level and then look up in 2011. And that's why we get January, February, March, and April. Now let's introduce a calculated member inside of our MDX query. Here we're going to use the with member, creating a new measure called year-to-date internet sales. We're going to aggregate based on the current member and the calendar date the internet sales. Now we can have a set in our columns of the first tuple, which is our internet sales, comma, the second tuple, which is the year-to-date sales. That's going to be on our columns. And then we'll just reference the month attribute and the calendar date hierarchies and use the members. Also, we're introducing here a where clause. We're going to say order date year 2012. So here's a variety of things that we have done in the past combined into one. We have with member, the aggregate, the new year-to-date function, as well as the members function and using the where clause to only find 2012. So we simplified this in a way by looking at all the data inside of the calendar date. Here now we're referencing all of 2012 and month by month each individual sales. Our second column is going to be the year-to-date sales for each one of those months. And if you add the 495 to 506, that's where you get the 1 million for February. So now we can actually see the growth month by month of sales. Year-to-date are YTD, QTT, TD, and YTD simplify the periods to date function. Let's open up another query window, and we're going to pick the descendants where we navigate up and down the hierarchies. The first thing we're going to do is just do a basic query where we get the internet sales and we look at the descendants of year 2011 separated by month. So here, based on that particular reference to descendants, we could see all the months of that particular year, which is 2011. The descendants function is inside of a set. We separate it by a parentheses. We reference the member data year 2011 that we want to look at the descendants, and then we specify what descendants we want. Self means look at the self and only, and then it's going to display those months for us. Now we're going to do something a little more complicated, but you can look at the power of using some of the things we've looked at. Here we're going to use the with member to create a new measure called percent of parent. The first thing we're going to do is wrap this in an if, because if the first part of the function returns a null, which is the is null comparison here, then we're going to display a null rather than an error. Else we're going to get the internet sales and divide it by the internet sales of the current member's parent. So we're actually calculating the percent of internet sales for the category as a whole. We've created this new member, we formatted it as a percent, we added it to our select on columns, and here we're displaying all the product categories. Let's run this and see what we get. And since we reference products by category hierarchy, you'll see that the all member is listed. And here we have the total internet sales overall. But if we look at just bikes category, we have 28 million, which is actually 96% of all sales. But then if we drill into the subcategory mountain bikes, we'll see that the 9.9 million is 35% of all. And then we can see the individual product, which is about 2%. And here we get a great list of the percent of parent. If you notice, you could make this a whole lot more powerful just by looking at the products within a subcategory or the subcategories within a category, or in this case, the all level. So now let's talk about managing the MDX in calculations. We saw earlier using the with member in an MDX. The with member statement lets you create new measures for an MDX query that follows an integration of that measure with the dimension and measures used in the MDX query. Once you get a good calculation in an MDX query, you can add it to the cube in the Calculations tab section. This enables the new measure to be shared in the cube and not just in the MDX query. This calculated measure can be rendered if the intersection of the dimension attribute or hierarchies are relevant. If not, if or case logic can be used to be cleaned up. The example to the right shows the sales amount as a sum of internet sales and reseller sales. Since the product dimension is conformed between the two fact tables, we can use an MDX query to show both measures as column values and slice by product category, using this hierarchy on the rows, and then you add the measure to the output. Once you get the hang of using the MDX with member, you can add those calculations to the cube. This shares the measure with all users of the cube and centralizes the calculation. It also reduces the requirement to have the calculated member in all MDX queries that are used for reports. The calculation tab is where this member can be added. The sales amount calculated measure in the cube is shown on the right, and it's not exactly an MDX query because you have a user interface to create it, but you can actually type the MDX as well. We have a member name or a measure name, sales amount, the hierarchy, measures, the expression, internet sales plus reseller sales, format, which is currency, visible, true, and is not associated with a measure group, but is put into a display folder called Sales Summary. So let's look at a demonstration of using the with member to create a new measure. We'll start by launching SQL Server Management Studio. I'm launching it from the desktop, but you can launch it from the Start menu. We'll connect to our default instance of analysis services, drill into the AdventureWorks DW 2014 Analysis Services database, and create a new query. We'll go ahead and open up a previously created file so we can look easily at what we're going to do. We're going to open this with members example, And first we'll look at a select statement that joins internet sales amount with reseller sales on columns and then looks at the non-empty calendar date year members. Once we launch that, we'll see 2010, 11, 12, 13, and 14 in internet sales next to reseller sales amount. The next statement is the member clause. Here we're going to say with member measures.sales amount, which means put a new measure named sales amount in the measures dimension as, and then we actually define the calculation. Here we're saying internet sales plus reseller sales, comma, formatted as currency. With that with member in our query, we can now launch it through the select statement that we had previously. Now we'll see the total sales amount alongside internet sales and reseller sales. So this is how to create a member property inside of an MDX query. But since this is a common calculation that we'd want in the cube, we're going to go ahead and open up the cube and add it there. We're going to minimize Management Studio and launch our SQL Server Data Tools. Here I'm going to open up a previously created solution. Once the solution is open, we're going to scroll down in the Solution Explorer to our cube and open it up. I'm going to go ahead and pin down the Properties and the Solution Explorer so we can see the Calculations tab. If we go to the Calculations tab, here's where we're able to add new measures. And if you notice, here's sales amount. You can see the GUI interface, but there's actually an icon on your toolbar to look at the script view. So if you notice here in the Calculate tab, we see our sales amount. And it says Create Member, which is just like the with member. And in our current cube, a new measure called sales amount as internet sales plus reseller sales formatted as currency. In addition, since we're in the cube, we're making it visible and make sure it's in the display folder called sales. So now when you actually browse this particular cube, you can see the internet sales along with reseller sales as well as sales summary. So we drag sales summary, internet sales, and reseller sales. We can get the same effect we saw with the with members. The other thing we had was order date by year, and we dragged its members across. Now we see each individual year, total sales amount, and internet sales and reseller sales. So once you get a calculation done in MDX, it's wise to review to see if it can be added to the whole cube so everybody can use it. Reporting a multidimensional cube can be accomplished by any tool that can connect to an analysis services database instance and be able to execute MDX against a database. Microsoft provides at least two tools, Excel with the pivot table option and reporting services. Excel provides a connection in the data ribbon and prompts the user to use a pivot table, pivot chart, or just to create a connection. Reporting Services is the Microsoft Business Intelligence Stack's main reporting tool. To connect to an analysis services database is easy, but there are some requirements for the MDX. Other Microsoft options are Performance Point and Power View, which gets integrated into SharePoint when installing reporting services on the same instance. Power View is being reworked into the Power BI option. The future looks really great, and in the near future you're going to see the integration of an acquired application called DataZen, which has different dashboards that can be viewed on mobile devices. Also, the Power BI desktop can be downloaded today and connected to a multidimensional cube. The Excel pivot tables is a very often used option in Excel. When you go into Excel, you go to the data ribbon, and there you can connect to an analysis services database from the other sources drop-down. Here, you see an example of selecting the products by category hierarchy for the rows of this pivot table. Then we place the order date calendar hierarchy on the columns. Lastly, you need to select a measure for the values in a pivot table. And here we have selected gross profit margin, which is actually a KPI. From here, you can create a pivot chart, add slicers, and improve the formatting to make the report presentable and interactive for the end user. With reporting services, or abbreviated SSRS, we can connect and create a data source in the analysis services instance and database connection through Add Data Source. The dataset will contain the MDX query to return data. The MDX statement has to have the measures on the columns, and this is important. So the best way they've created for you to do that is to use what's called the Query Designer, which lets you drag and drop objects into a query window. This will help build the MDX for you, which you can later edit. You can enter MDX, but make sure it is correct in Management Studio before using in a dataset. In the Query Designer, you can create a parameter list to be used when executing the report. The parameter is created in the Filter area of the Query Designer. You need to select a hierarchy or attribute to filter before a parameter can be created. Reporting services will create a hidden MDX, which you can unhide, to populate the drop-down for the parameter assigned in the filter. This is very, very helpful. Next is to design the report. There's a toolbar available to show all components that can be used. A simple table is shown here that can have column headings and rows of data. Groups and subtotals can also be created after the detail line is completed. And finally, there's a preview tab, and you can execute the report and preview the results for fine-tuning. Now we're going to demonstrate creating reports in Excel and also in reporting services. First, we're going to want to launch Excel. Now I'm going to do this from the Start menu. And once we get an Excel spreadsheet open, we'll create a blank workbook. Here, if you go to the Data ribbon, you will see in Get External Data. Here, there's one that says From Other Sources, and then we have an option From Analysis Services. It prompts us for a server name, which we're going to do the default instance. Click Next, and prompted with the different databases. Here we're going to select AdventureWorks DW 2014. Inside of a cube you have the option of picking the cube or even a perspective created within the cube. If you remember from designing cubes, a perspective is a subset or view of the main cube. It enables users to only see the measures and dimensions they want to work with. In this case, we can just select Internet Sales and click Next. It prompts us for an ODC file to be placed either locally on our server, and you can put descriptions, friendly names, and even search keywords. There's also a way to create authenticated settings if you're using Excel services. We'll keep the defaults and click Finish. Next, you're prompted on how you want to display the data. The first option is the pivot table, and then you have a pivot chart. There's even an option for Power View in this case, and also only to create a connection. The last thing is to specify where in the spreadsheet you want to create your pivot table. I'm going to select B2 in order to leave a gap above and to the left of our pivot table. There's also a Properties button that lets you change some of the refresh options. If you see in this case, the refresh data when opening file is not checked. If that is not checked and new data is compiled into the cube, the user will not see the new data. So it's a good idea to check that. Also, if you want to look at the definition of the connection string and change anything in here, like add a row, you can do that. We're going to click OK, and it's going to create a pivot table for us. It's starting in B2. Since we used a perspective, we have a limited amount of measures, KPIs, and dimensions. The first thing we're going to do is look at product, and we're going to drag the product category to our rows. Now we have a list of bikes, clothing, and accessories. Next, under order date, we're going to grab the calendar date and put it in our columns. Now we have a good cross-tab of data. We can even drill into the year, because this is a hierarchy, and the quarter as well as the month. We're going to zip those back up and then select our measure. We're going to drill into internet sales, and we're going to put the gross profit margin out there. I'm going to hide the pivot table fields toolbar, and now you can see more clearly the pivot table. You can also see that there's a subtotal when we drill into year. We can right click on that and actually remove the subtotal for year, as well as grand totals on the top and the bottom. And here we have a nice drillable pivot table to look at categories by calendar year. That's all we're going to do in Excel, and I'm going to minimize that. Next, we're going to launch SQL Server Data Tools. This is the Visual Studio shell for business intelligence projects. We'll go to the File menu, New, and create a new project. Here we're prompted for either the Business Intelligence Analysis Services projects, integration services, or reporting services. We're going to go ahead and create a project and give it a name. Once that's created, we'll get a blank screen. Here we have the Solution Explorer, which has 3 folders. You can actually share data sources and data sets between reports in one centralized place. We're going to go to Reports, right click, and add a new item. If you add new report, it's going to go through a wizard, and we want to create this from scratch. So I'm going to highlight Report as an object type and just call this Reseller Sales. Well, we'll make it Internet Sales, which is more in line to what we did inside of Excel. I'm going to click Add, and we get a new report with kind of a blank surface to design. Also on the bottom, row groups and column groups. Before we can design any report, we need a data source. So we're going to right click on data sources and add data source. Here we're going to call this Internet Sales, and we're going to embed the connection, but our type is not Microsoft SQL Server, it's Microsoft SQL Server Analysis Services. Next, we need a connection string, and there's an edit button to design this. Here we're going to give the default instance, and we need to select the database name. We're going to select AdventureWorks DW 2014. You can test the connection to make sure it does have access to it, and then click OK, OK again, and the last thing is the credentials. We're going to use the Windows authentication, which is integrated security, for this report. We'll click OK, and the next item is a data set. Here we right click data sets, and this is going to help us build a data set. The data set is also where we can use the query designer in order to get the MDX. If we wanted to, we could go to Management Studio. Once Management Studio is launched, we can connect to that instance and actually type our own MDX. Here I have some pre-formatted MDX. I could grab this data, right click it, and copy, and go back to my project and actually embed it inside the data set. As we right click on data set, we need to give it a name, and we want to use a data set embedded in the report. We'll select the data source that we just created, and here we click the query designer to bring up a prompt. We can actually import from that MDX if we wanted to and actually copy and paste the file we just used. But we're not going to do that. We're going to interactively build our MDX. Here I'm going to drill into measures and internet sales, and I'm going to pull the gross profit margin over to the display area. Next, I'm going to go to products and pull the product category hierarchy into this display area. The last thing I want to do is create a filter to filter this report. I'm going to use product category, put it in the select dimensions in the filter, and I'm actually going to give it a filter expression and say just bikes. Now this thing is just filtered by the bikes. The last thing we'll look at here is something called parameters. All reports usually have some sort of prompt. If your application like .NET wants to pass parameters, it can through when you deploy the reporting services report to a server. But here we're going to let it create it for us. We'll click the parameters, and now we actually have a parameter for this report. There on the toolbar, there's a design mode that lets you look at the MDX created, and you'll notice some of this if string to set for that at product category. It's actually formatting this for us without us having to type anything. We'll go back to design mode, and we're going to click OK. Now we have a parameter created to prompt us for that, and we have the field selected that we want inside of the report. I'm going to click OK, and now we actually have a data set. Now if we right click that data set, there's going to be an option in just a second. It's actually processing the MDX right now, and it's going to show us that hidden set. So when we click the parameter, it actually gave us a new query in order to populate that particular column. But what we're going to have to do is unhide it if we actually want to look at it. The parameter is really a nice option to give to us, but we can show that hidden data set, and here it is. This is actually an MDX statement that's going to populate that particular parameter. And if we go to design mode, we actually run this and see what's returned. And you see that it's a list of product categories along with a parameter value, which is the proper MDX ordinal value, as well as the parameter level. All levels on top, and then the 1 levels below that particular hierarchy. I'm going to click cancel and then look at one last thing. Here we're viewing the report data, but if you notice on the bottom there's other tabs. One of them is toolbox, and what we're going to do is we're going to grab a table and drag it to our report surface. Now we can actually go back to the report data and drag those columns we want in the report. We're going to drag subcategory and gross profit margin, and then click the preview button. The preview button is going to let us run the report, and it's going to actually build that list of product categories, and it's selected by default bikes. I can uncheck that and pick accessories and then rerun the report, and now I get the accessories for the bike. That's a brief demonstration of reporting services. There's other options in here as well as creating subtotals. We can add totals before or after, look at a preview, and then we see the gross profit margin before. We can actually tell it to use the aggregate function rather than the sum. And we can right click, edit the expression, and change sum to aggregate. Since gross profit margin is a percent and not a sum, we need to use the aggregate MDX value instead of sum. And then we'll actually get the proper data for that. That is a great demonstration of reporting services and using MDX in your reporting services. There's other options available to learn more about reporting services, but here we just wanted to learn how to use MDX inside of a reporting tool.